So Colin, unfortunately, was unable to make his flight, but it looks like we got the video working. So Colin, I'm going to go ahead and hand it over to you.
Great. Thank you very much. So I'm going to start by saying thank you. I assume there's some people in the audience, so thank you very much. I also want to thank RStudio both for inviting me and also for allowing me to do this via video conference. So they were very amenable to helping me out. And I also want to apologize because RStudio didn't quite figure out that there's no one here to tell me to be quiet. So I'm going to aim for around about 19 minutes, but there's no one in front of me to tell me to sit down and shut up, although I suppose you could walk out. So, a bit about me. So my name is Colin Gillespie, and I got roped into writing this book with Robin a few years ago on efficient R programming. And I also co-founded the company Jumping Rivers. So we've got a little stall at the conference, which, since I've not seen any other stalls in the conference as I'm in Newcastle, I'm sure it's the best stall there, so please drop by and say hello to the folks there. So, what I'm going to be talking about is a hackathon that we participated in a couple of years ago. So this is the Northumbrian Water Innovation Festival. So this is an event that's held every year. So it was held last year and it's going to be held again this year. And it's got the word innovation in it because the government in the UK said to water companies, you have to be innovative, and the best way of demonstrating innovation is to have a festival with the word innovation. So this festival runs around about July, and it's quite a big deal, so it runs for the entire week. There's round about 15 to 20 hacks. Some of them are data, so that's the one I'll be describing. And on the other end of the spectrum, there's more engineering about designing widgets and robots and things to detect or help the water network. So, the way the week was structured was there was 2 days of background. So Monday and Tuesday, there was a series of seminars, series of lectures from different people in the water organization telling the participants what was sort of going on. Then on the Wednesday and on the Thursday, there was the 2 hack days that we were involved in, and there was round about 10 teams in total. Okay, so there's 10 teams, and for each of the 15 to 20 hacks, so it was, as I said, a big event. So we were competing against another sort of 9 teams in the event. The goal of this hack was to reduce leaks by 20%. I have to be honest, I'm currently sitting in Newcastle in England, and I'm looking outside and it's rather wet and damp, and I'm wondering of why this was a goal, but this was a goal they wanted to reduce leaks, so that was what we were aiming to do. So what we were given was data, lots and lots of data. So on the Wednesday, we were given access to an Azure drive in the cloud, okay, and inside this Azure drive, there's around about sort of 5 to 8 gigabytes worth of data. There was some spatial data. So Northumbrian Water has 2 sites in the UK, one up by the border in Northumbria in England, and then down in the south. Okay, so sort of 2 regions, and we had spatial data on that. We had time series, so we had data on sort of 15-minute intervals. We had data on hourly, weekly, monthly intervals. So we had lots of different types of time series with all the fun you could imagine with that. We had leakage estimates, so how much water was actually lost due to leakage. We had flow rates, so in the UK, you can imagine how the water sort of authority, the water companies have evolved over the last few decades. And we have something called a DMA. So a DMA is a district metered area, and it's a collection of zones of postcodes. Some are quite big, some are quite small, and the flow rate is just how much water is passing through. We have how much water is being used by people. We've got the reported leaks. It's basically an Excel spreadsheet with some dates, times, postcodes, and sort of what the person said over the phone. We've got pipe size. So that was measurements in metric, so centimeters, millimeters, imperial UK, imperial US, imperial Roman, you name it, we had those in sizes. With pipe location, that was more an indication rather than an exact measurement, again, pipes have been laid over the UK for decades. So they knew there was a pipe on this road, somewhere on this road, and they just hoped for the best. We've got pipe type, so you've got plastic, you've got metal. Turns out there's also asbestos, which I have to be honest worried me somewhat. But asbestos, we were told, was fine as long as no one drills into it, so we're all safe. We've got social data. That's basically saying, you know, who's living in the area. Is it students, is it families, is it business, what sort of mixture? We've got weather, rain, sun, not so often, but how much rain we've got. How much business, you know, what sort of businesses are nearby, what their usage. And then we've got stuff. And what I'm guessing is someone had a week to put this data together. The first 4 days, they got all the stuff on the right, and then they spent the last day just putting in other stuff. And I can't remember what the other stuff was, but it's just general stuff that I thought might be interesting. So this is what we had. And the problem setup that we were given is a very sort of standard, I would say, sort of machine learning framework. Okay, so we've got all this data, all the data that you would think would give you an insight to leakage. Okay, and we've got all the previous results. So we've got leakage from the past sort of 2, 3, 5 years. We've got covariates or predictors that we think would be useful. So weather, businesses, pipe type, pipe size. Intuitively, you'd think if the pipe was older, then it might break. Intuitively, you'd think, well, if a pipe is made of lead, then that's more likely to have a leak than a pipe made of plastic. Okay? And so we're sort of led up to this very sort of classic machine learning problem of lots of data, now put it into your computer, turn the handle, and try and predict what's going to happen. And in my head, I had this amazing algorithm that would tell someone the precise coordinates of where the next leak was going to happen, and engineers would rush out and fix the leak before anything would happen. That's what I thought would happen. So this is me, approximately like this, and I worked hard all day. Right? So this was a Wednesday, and I started coding about 9:15 on the Wednesday. So just got the data, and I opened up the folder, and I looked at it, and I automatically went to work. Right? So I was a dplyr machine. Hadley would have been proud. Okay, this was amazing. You know, it turns out that there's multiple ways of spelling DMA. You'd think there's only one way of spelling DMA, but they spelled DMA multiple times. So there's lots of left joins, right joins, every join you can imagine. I even did some AI, or regression, as I like to call it. So I did some regression. I even did some boosty, baggy tree things, you know, to try and predict what was happening. You know, I was working hard all day. You know, I was doing what I was told. This is Seb, an exact likeness, and Seb had a different strategy. So we were in the same team. So Seb is also in the booth, jumping rivers at San Francisco. So please go and embarrass him about this. So Seb spent all day drinking coffee, and Seb ate hobnobs as well. And so if you don't know what a hobnob is, it's a top-class biscuit made in the UK. And Seb asked questions. So in this room there were 10 teams, and then there were a bunch of tables where people from Northumbrian Water were there ready to answer questions. And there were some people who were engineers, there were some people who were sort of in charge of the analytics, some people who were in charge of customer service, just, you know, people on tables who were waiting for questions. So Seb would walk around drinking his coffee, eating his hobnobs, and having a nice jolly old time while I was working hard. And I was vexed, I have to be honest, okay? So I was doing all the work, and I wanted to eat hobnobs, and I wasn't getting very many hobnobs. I was drinking lots of coffee, and if I'm being truthful, I sort of started jumping rivers to avoid doing work. You know, that's what all founding a company is. It's about skiving from work. And, well, I seem to be doing lots of work, and Seb seemed to be wandering around doing no work whatsoever. So, do you remember back at the start, the goal of the hackathon was to reduce leaks by 20%. And that's sort of an obvious thing, you know. Who wouldn't want to reduce leaks by 20%? But a more obvious question, or a less obvious question, is why, you know, why 20%? You know, why reduce leaks? You know, is it a big problem? And after chatting with a few people, Seb found out, and essentially they get charged a lot. Okay, so they're wanting to reduce leaks because they're going to be charged an awful lot of money. And next year they're going to be charged even more money, and the year after that they're going to be charged even more money again. So each year they're going to get charged more and more money for having leakage. So the goal wasn't to reduce leaks by 20%. The goal was really to reduce the amount lost due to leakage. And they're both similar ideas, but if at the end of the year you had 10,000 leaks but lost very little water, then that solves the second one but not the first one. And that's what they were wanting. They were wanting to reduce the amount lost due to leakage. Didn't really care about leaks, it's just the overall amount. So that's the first thing. Second one is, how do you estimate leakage? Now in the UK, you pick up a newspaper and you read something like the amount lost due to leakage, was 5,323 litres and 3 teaspoons, and you think, they've got that measured, that's accurate, lots of decimal places, we know exactly what's going on, right? This isn't made up. Well, what happens in practice is you have a DMA, so a DMA is just a collection of zones, so postcodes, again, some are quite big, and the thought process goes, well, we know how much water is going into the DMA, we know how much water is going out, that's how much water is being used, and well, no one would use water at 3 o'clock in the morning. So any water being used at 3 o'clock in the morning must be a leak, which isn't the most precise of measurements when you think about it over the course of 2 seconds. And Northumbrian Water know this, right? They know this, it's not a surprise, they know this measurement is, shall we say, noisy or imprecise. There's nothing they can do about it, and we're currently working with another company to actually measure soil temperature and do a bit of prediction. But what we have on that day is that's the column that says leakage. It's the minimum flow rate at 3 o'clock in the morning. Would you believe that at New Year's Day, the leakage goes through the roof? Turns out that people are up at 3 o'clock in the morning. So that's what they have. What do you need to fix leaks? Well, you need an engineer and you need data. Okay? So the engineer is obvious, right? You need someone to go out there, probably in a van, with some tools to fix a leak. What data do we need? Well, when an engineer goes out, so they're told there's a leak at this region, well, they want to know what's the flow rate, how much water is being used, what's the pipe type, right? Is it steel, is it plastic, is it asbestos? What's the historical leakage? Was there someone in the team that went there last week and perhaps it's the same thing again? What's the weather? Is it sunny? Is it raining? They sort of need to be able to predict this because that could cause problems. Traffic, allegedly they're not allowed to just dig up roads when they feel like it, and so if it's a main road, they have to sort of schedule that at night time. Crime, do they need to bring a friend to watch the van when they're going looking for leaks? And this takes them 2 hours per day to get this information. So every single day an engineer walks in and they say there's a leak at this area, and they spend 2 hours getting all this information. All this information that we've just been given for the hack. There's 35 engineers. Engineers aren't cheap. And currently have, every morning, 2 hours, 35 engineers spends trying to get all this data together. So our solution is not to try and predict leaks. When I say our, this was Seb's solution, to be perfectly honest, but I'll go for our now. Our solution is not to try and predict where leaks are going to happen, but to reduce engineering time. Right? We can get that 2 hours down to about 10 or 15 minutes. It's just giving them the data that they need. And this is relatively easy, and it's definitely doable, right? There's not a sort of R² or predictive value or anything like that. It's just about they have data in one place, we're wanting to make it accessible in another. So this we can definitely do. Now, we're now on day 2 of the hack, right? So, and on the second half of the day, we have to do a presentation of what we've built. So we've got half a day to do an app, and there's myself and Seb. So what we need to do is we need to decide what we're going to make and decide what to bluff, or lie, or pretend, or whatever you want to call. So for example, if we can demo a single DMA, we don't need to show 2, 3, 4, 5. We can do one, we don't need to do more. If we can display pipe location, we don't need to tell them about pipe type. That's obvious, we must be able to do it. Okay, so we decided what to make and what to bluff. So this is a screenshot of the winning app. This first screenshot contains lots of bluffing. So for example, in the top left-hand corner, there's a little person that indicates we've got authentication. We can do authentication. We do authentication for our customers. We did not do authentication on that half a day. We've got some high priority DMAs, all bluffed. We can do that. We didn't need to do that in a day. Here we've got a screenshot of what an engineer could possibly see. So this was a long sort of column of different graphs and different data. The first couple of graphs were nice and busy and interactive. The last few graphs were a bit more static in nature. And if you look at that little sort of blue slider, when that was clicked on, the graph was going grey, and that was indicating that it wasn't going to be part of an overall report the engineer would take with them. Also an idea about taking a picture and then being able to upload it onto the app. Again, we didn't do this, it was just an indication. And this was all done using lots of dplyr, ggplot, Shiny app, and all done in half a day, because we had to demo it. So the app is now being used in production. I'm the second person on the right, sort of the tall, baldy chap. And I would love to show you screenshots, but because it's got national infrastructure data, it's got locations of pipes, we can't just sort of show screenshots easily. So that was when we won it 2 years ago. We also won it this year as well, so sorry for bragging about that, but we won this year's hackathon as well. And we also won that one as well, so I'm not really sorry at all about bragging. I'm now just bragging completely. So, summary. It's obvious, but think about your problem. And if someone told me before the hack, I would say, of course you think about your problem. But I really didn't. I jumped in with both feet. I'm good at dplyr, I'm good at R, I'm good at building models, and I went straight for that. And that's not the best way. Talk to people, ask them what the problem really is. Also, don't send me to hackathon without others. So the one hackathon that we've lost is the only one that I've been to by myself, so that's somewhat embarrassing. So I'm now in this strange situation where if the team going to hack, I'm not sure if I want them to win or lose, because, yeah. Anyway, so thank you very much for listening. Sorry I couldn't join you over in San Francisco. It's really painful watching Twitter and just seeing all this isn't RStudio conference absolutely wonderful. So it's painful over in Newcastle. And by all means, please come over and say hi, not to me, but to Seb and the others at the stall. And thank you very much for listening. Thanks.
Thank you so much, Colin. That was great. Do you have any advice on where to find some hackathons in North America?
Not so many, not so much. Typically, one should no would be my answer. I think you've caught me with that question. I suspect user groups would know. So if you're part of an R user group or a data science user group, typically any hackathons would approach the user group first of all for a bit of advertising. So that's where I think you'd find. And once you sort of stumble into that field, you then find them everywhere.
Awesome. Well, thank you so much for joining us from the UK. We really appreciate it. So this concludes this track. And I believe lunch is going to be served somewhere out there around 1 p.m. So thank you so much.